booking.com. Some of you probably know me.
Who are you?
Liz is in the audience, which is cool because Liz is sort of indirectly responsible for Sereal, because she invented something that we'll talk about a bit later in the presentation. Just hope you guys are all doing well today and stuff like that. And I'm a little bit nervous, so bear with me. I'll get into my flow as I pick it up. I've never given this talk exactly like this before, yeah, apologies in advance. So this talk is about Sereal. What is Sereal? Sereal is a schemaless binary protocol for storing data from a dynamic language, obviously originally designed to handle Perl, which means it handles all sane Perl data types. So for instance, it does not handle globs. I would not consider that to be a sane data type. And it doesn't store code. Now you could argue whether or not that's sane or not, but our general impression is that serializing code usually causes trouble, and that just simply not allowing it avoids a lot of trouble, and that usually you can get the same effects without having to serialize your code. So we don't really feel that bad about that one. In particular, and somewhat different from a lot of the other competitor modules that will often be mentioned in discussions about serialization, it has proper support for cyclic data structures and aliases and some of the more unusual constructs that you can make in Perl that, for instance, you typically don't see in other languages for one reason or another. Whether or not that's good or bad, well, it not being in the other languages is a personal opinion, I suppose. And it's obviously implemented in excess for performance and accuracy, and plain and simply, you cannot tell whether or not a Perl value contains an integer in Perl. You can do it in C, you can sort of hazily guess in Perl, but whether or not Perl actually thinks something is an integer versus you thinking it's an integer is another question. So for example, a very large integer in Perl might actually be stored as a float. So if you write a 50-digit integer, Perl will silently convert that to a float and truncate some of the precision off of that value, right? Being helpful, of course. That's the kind of scenario where it's very difficult in Perl to do the right thing, and do the right thing efficiently as well. So everybody that just heard that description that has any experience in Perl is probably thinking to themselves, that's storable. You just described storable. And it's true. The whole point was to replace storable. Storable is evil. It's plain and simply evil. And there's many reasons actually, but the most one is this. It stops you from upgrading Perl. The single largest barrier to upgrading Perl at booking.com for many, many years was Storable. We had Storable buried in all of our databases, we had Storable in our cookies, we had Storable in our mem caches, we had Storable anywhere that you could basically serialize data, pretty much, we had data in Storable, and it meant that you couldn't upgrade Perl. And I'll explain why. We call this the Storable upgrade trap. That's...
We can make it one. We have the technology to make it one.
Just because you can doesn't mean you should. So the Storable upgrade trap, and I think this is something that every enterprise user of Storable should be aware of. Storable claims to be backwards compatible, and to a certain extent it is. A new Storable can read an old Storable data. But the problem is that a new Storable can only write the new format. Now, for a very long time, the first thing that Storable did when it opened up a packet was check the version number in the packet. The version number was newer than it was, higher than it was, right? It would just simply die. right? Which meant that there was no way to get any useful data out of it at all, which meant that basically you had to downgrade your Perl because, well, Storable's distributed with Perl, so you have to downgrade your Perl to read your data.
Now the world hates you.
It actually turns out that somewhat in response to probably people like myself pointing out that Storable is actually really dangerous, there were some improvements made. So now it doesn't actually die when it reads the version number. It just dies when it finds something in the serialized packet that it doesn't know how to process. But from my point of view, that's basically like, okay, so now I went from I know it will die to it's going to randomly die when I don't want to, right? Which from my point of view is not an improvement, right? I mean, yes, it probably means that if you're very careful about what data you put into Storable, right, that you can probably get it out again, right? On the other hand, Storable just allows you to pass it a reference and then it serializes the whole thing and it doesn't really care what's in there, right? So that then means that you would have to walk the data structure first or something to find the things that shouldn't be there and then remove them or whatever. I mean, you certainly can't have a situation like we do where people just randomly add stuff to these blobs and then we serialize them and it all just works, right? That would just break. So if you upgrade Perl, you upgrade Storable. So then the question happens, what happens when you cannot upgrade all your machines at the same time? Perl, like Booking.com, to give you an example, has like, I think it's currently something like 800 web servers, right? We simply cannot upgrade all 800 web servers at the same time. It's physically impossible, right? Even if we really wanted to, we couldn't do it, right? We don't want to because they make us money, right? So turning them all off for 5 minutes so we can upgrade Perl is not an option, right? Which means that we have to have different versions of Perl running in our ecosystem. Now that was just our front-end web servers. If you include our back-end processing servers and things like this, the number of boxes running various different versions of Perl of Booking is counted in the thousands, okay? So we can't upgrade, like, we can't simply upgrade app, our front-end web environment by itself, and there's no way in hell we could upgrade all of our web environments and all of our back-end processing and et cetera all at once. So we were kind of stuck, and you know, there was, I think it was relatively well known in the Perl community that Booking was stuck on Perl 5.8 for a long time. And Storable was pretty well the main reason. So yeah, what happens when you need to do that? Pain. So there's other problems with Storable, security problems. And these issues are actually not confined to Storable. In many cases, a lot of them actually pop up in other serialization and deserialization packages. They bless objects too early. And where this is important is if you bless a bunch of objects as you're deserializing, and then you encounter an error in the packet you're deserializing, you typically will throw an exception, which will then cause all of those objects to be destroyed, okay? Now, if those objects to be destroyed are something like, you know, object malicious, which is going to do an RMRF and destroy, right? Well, you have a problem, right? In our case, it was more like we have some old class DBI derivative objects that maintain some state about whether or not they've been updated. And the main place that we experienced issues was people serializing not written out records into an object. Then we would deserialize them later, right? And then wonder, how could this destroy happen? Nobody ever looked at that object in this code path, right? And very strange bugs like that. To make it worse, Storable and some other serialization packages are trying to be helpful and will load modules for you. I personally think this is really evil and wrong. If you want to load code, you should explicitly load code. Your serialization package should not decide to load it for you, right? I would prefer my code to error because some object got deserialized that doesn't actually have any package definition or something, and something calls a method on it, so I know what's going on, than have packages magically get loaded into my namespace. Especially when perhaps somebody is able to like remotely control it. So imagine somebody hacked like CPAN and was able to create some deadly object that they then embedded in a package that's very commonly used, right? People would then upgrade, install this deadly package as a side effect, right? And now you have a way of like, via a storable package, causing that module to be loaded. Another problem is that many serialization packages don't actually pay attention to make sure that a serialization is canonical. So what that means is that, for instance, JSON XS will not, on deserialize, check to make sure that a key hasn't been duplicated in a hash. Okay? So, for instance, it's quite possible to construct a JSON package just as you could construct a Perl hash that has x1 and then x2, right? And we would all expect 2 to be the value of x after that. But imagine when the 1 there was actually object deadly, right? Now you would deserialize your code, right? And you would never even see that somebody had injected an object deadly into your namespace that then did stuff on destroy that you weren't knowing about, right? So basically there's a lot of holes in these modules that are subtle security issues that basically mean I must control all of my data, right? If I allow an arbitrary attacker to provide me a packet and I then try to deserialize it, basically I am actually vulnerable to some of these things. Now I don't think JSON XS is stupid enough to autoload modules for you. I haven't checked, but I'm pretty sure Mark Lehman wouldn't do that, I hope. Other modules, especially ones that are aimed at being helpful, wouldn't surprise me if they do. Storable certainly does. Sereal, on the other hand, takes some very, takes proactive measures to avoid this. It does not bless anything until the entire data dump has been deserialized. So it actually remembers all the objects that need to be blessed, and only at the very end, when it knows it has processed a complete serial packet and that it's okay and it's not going to die, will it then go and bless those objects. So basically, you're guaranteed that destroy will never be called by any deserialized object within Sereal. And it does similar things like it will basically complain if you try to have 2 keys. Sereal would never produce such a data output, and Sereal will notice if somebody tries to feed it to it and say, no, that's not correct. Now, a lot of people are probably asking, why didn't you just fix Storable? Which I think is a fair question. The problem is that Storable has no spec. It's basically a big blob of nasty code. It uses a bunch of funky tricks internally that, to be honest, I know internals pretty well, and I didn't really grok all of them. It was kind of one of those things where like we can spend a year reverse engineering how Storable works and then make it possible to like deparse older Storables and la 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 la, or we can just move on. Since there were design flaws, like the security issues that we just mentioned, and the basic problem for us, if you're trying to serialize to go to the wire, you don't want to produce large dumps. The intention of Storable is to produce an exactly accurate image of what was in your Perl process, right? Including some really bizarre stuff like dual vars, right? So variables that have a different string representation than their integer representation, right? Storable will handle those properly. Sereal will not, by design. We don't consider that to be a sane variable type. Nor does actually Perl. If you do nearly anything with a dual var, it'll stop being a dual var. So, and be careful. Don't confuse dual vars with things like $! Exclamation point. It's actually a tie, not a dual var, even though it looks like a dual var. So the combination of the security issues and the large output size meant that it wasn't like perfect for going to the Y. So we created Sereal. The first thing we did was we started with a specification. I sort of lie here. The first thing that we did was we started with about a third of a specification. Then we systematically went through and made sure that that specification supported everything that was in Perl and updated the specification as we went along. But the point was that when we released version 1 of Sereal, there was a spec. And a bunch of people actually jumped on that and started hacking in other languages. If anybody's interested in improving those efforts, we are very welcome to patches. If anybody wants to write a Sereal module for a different language, we're very open to adding new languages to our main repo. We structured the repo from the very beginning to have a different subdirectory per language. So we actually have a number, and I'll get to that a bit more. An important part for us was that we have a separate header and body, and I'm going to get into that in a little bit. Another important feature for us was that it had some form of compression. We thought about putting some compressive elements in the protocol that might actually come in a future version of the protocol, but for now we rely on Snappy and then as of version 3 gzip support. So Snappy if you want really fast but not the greatest compression, gzip if you want really good compression at the cost of some performance. In general, we tried to be as fast as we could, but you know, it's one of those must be correct first, then fast. And the other thing was there were a few places where we traded size for speed. So an example is we serialize integers, for example, as a data structure called a varint. Which is basically the reverse of what Perl calls Burr encoded integers, if anybody's ever used them, the W format in PAC. Varint is actually the opposite of that in that it's little endian instead of big endian. But other than that, Google varints are, a varint is a sequence of 7-bit bytes where the high bit says that there's another byte coming, and then you just keep shifting on the low 7 bits. So we use that for integers. So basically we can represent many large integers in as few bytes as possible with as minimal overhead as possible. We specifically from the very beginning built the decoder and encoder as 2 separate packages. So what we do at Booking when we need to roll out a new version of the protocol is we deploy the decoder everywhere, and that could take like, let's say a week, right? The new decoder will then be capable of reading new encodings. It's also capable of reading old encodings. Then once the new decoder has been deployed everywhere in our systems, we deploy the encoder. So then, you know, as bit by bit systems switch over, they're all prepared to read it with the decoder. Not only that, we also built in support into the encoder so you can specify the version it produces. So if necessary, you can use the latest version and say, I want version 1 format so that I can talk to some system that hasn't been, for some reason, can't be upgraded. It happens more often than not. Well, more often than it should, I guess is what and then another thing that we tried to do was we take advantage of a number of internal implementation details of how Perl itself works. This is one place where using Sereal in another language may not be quite as efficient as using Sereal would be in Perl, in that Perl does a number of things itself that Sereal is able to take advantage of to enable you to produce more compact DOM. And I'll speak a bit more about that in a minute. So what do we use it for? We store data in memcache using it, event data. Liz, a number of years ago, introduced a critical system to Booking.com, which is basically something like syslog ng on steroids using structured data logging elements that are nowadays encoded in Sereal. So every time we display a web page at Booking.com, we construct a serial packet and send that off to a centralized logging system, which then allows that data to be disseminated into Hadoop. We can tap into it real time using various command line tools that we have, so that we can watch everything that's happening on our web servers basically in near real time with a couple of seconds latency sort of thing. We make heavy use of this for everything from asynchronous processing pipelines to real-time monitoring to attack diagnosis. When we've been attacked, it's using this subsystem and the data it provides is one of our main ways of finding the pattern of the attacker and things like that. We have all the data that we could possibly need in these events. We use it for storing data in MySQL. There are places where we need to construct pre-compute large blobs of data and then store them in the database so that they can be reused many times. We've also found uses for it doing very simple IPC and sort of thread pool type, fork pool type setups where you fork a bunch of children, they all process part of your job. At the end of their processing, they write serial packets, which are then read back by the mother process. We actually plan to make Sereal even better at doing that, so using probably memmap will avoid all the marshalling costs of moving the data between the different processes. This gives us a relatively simple, easy to understand, and sane form of IPC. There are probably better ways to do IPC, but they lack one of the other three words, like simple, sane, or whatever. I suppose it depends how smart you are. But so, what other cool features do we have? So one of the ones I mentioned earlier about taking advantage of how Perl works. Perl, many people don't know this, but Perl has something called PL. The C name for the variable is called PL stir tab. It's a hash table that's not visible in Perl from the Perl side of your code. And it contains every single hash that has been stored in your process, with the exception of a special class of hash that almost never you would. Basically, basically, if you don't know about it, you don't need to know about it, and if you know about it, I don't need to explain it to you. So, what this means is that this was originally done because in Perl we use hashes for objects, of course, and if you have 100,000 objects that all have the same key, well, it's not very efficient to store that key 100,000 times. So what Perl does is it actually has a master key table that stores every key that is in any hash in your process in a single hash. And then what it actually does is it shares the data structures that contain this key amongst all the hashes. Now what this means is that, that Sereal can actually identify a key by the address that it's stored at, and then basically keep track of the fact that it's already seen it. So if Sereal has to produce an output that contains the same key duplicated, it will only output the key once, and then every other time in the dump, it will actually reference that original emission. So going back to the event pipeline, part of how our event pipeline works is that we have these listeners that are listening to events that are being sent to them one by one. Every second, they basically deserialize all of these events and then reserialize them back into an array of hashes. So it goes from being a serialized hash to being a serialized array of hashes. In process, we reduce the output size of that data set by about 40% just by deduping out all the keys and class names. And that's it's nearly free. We do an integer hash on the address of the pointer containing the key, which is very fast. We have some facilities in there to identify strings and dedupe them. This is somewhat independent of the automatic deduping. You would have to enable that. It has a performance hit. We'll probably actually work on improving the performance of that someday, but it's not a high priority for us. We have support for deserializing data read-only. This isn't quite as useful as we had hoped it would be, in that Perl is actually really confused about what the read-only flag means, and it will probably be Perl 522 before we sort out that mess. Unfortunately, the read-only flag has meanings at the Perl level that basically mean this variable shouldn't be modified, and then in the internal levels it means I am diddling with this variable and like none of the normal rules actually make any sense, and the problem is the two definitions conflict. Father Chrysostomos has actually now introduced a new bit, so read-only becomes truly the read-only that we expect it would be, and not the this SV is special, don't touch it flag. So maybe when in 522 we'll see that being a bit more useful. Not only that, but like read-only hashes are really useless. Has anybody ever noticed that? Has anybody ever tried locking a hash? So try locking a hash and see how much of your code dies, right? You'll be really surprised to find that virtually all of it dies. The expectation that you can ask a hash for a key that it doesn't contain without the hash dying is deeply embedded in how things happen. And I personally think it's a major design fail that doing that, especially with an operator like exists, will actually cause a fatal error. So I consider the whole lock hashes thing to basically be completely useless and a performance hit on Perl internals. If anybody actually knows of a real good use for them, feel free to send me an email and explain, but yeah, don't try too hard to find the use. So another really interesting thing is this next one, deserializing duplicated integers as aliases. This is a kind of interesting example where we have some processing systems that basically use Sereal to write out arrays with like hundreds of thousands of integers in them, okay? And we use this for various aggregation processes and stuff like this. Now, every time it encounters a 0, right, Sereal has got to basically construct an SV that contains the value 0. The overhead, this SV will probably be, I guess it's going to be 16 bytes, just to hold the value 0, right? So if you have like a few million of those in your process, it adds up. It takes time to allocate that memory, do the bookkeeping for managing that memory. So in a case where you know that you're not going to ever touch the data structure and modify these variables, but where you're just going to read them out and then do sums on them or something like that, you can set an option to basically tell Perl to alias all of those integers together. So now there will only be one 0. It will just be shared all over the place, and there will only be one 1, and you can actually select, like, do I want to do this for the range of 0 to 100,000? You know, you could be really mental and say I want to do it from 0 to a billion or whatever. If you had enough memory, it's your choice. And then another point that I think is a cool feature is new encoders. What I mentioned earlier, we can produce old protocol versions. So I mentioned headers. This I think is one of the cooler parts in some ways of what we've done with Sereal. Every Sereal packet has a header. The header performs a number of functions. It's a magic number that I believe there's actually a patch for file. So if you say file, Sereal file, it should say Sereal packet or something. And we made our header a little more intelligent than a lot of headers might be, I suppose, in a serialization packet. In that we actually allow data to be stored in the header independently from the body. So there's actually, a Sereal packet actually has the capability of containing 2 Sereal packets within it, or 2 data structures within it. The body is compressible, okay? And the body is where you want to put your data. And, you know, under normal circumstances, you wouldn't put any data in the header at all, and you have to go through some fairly clunky APIs to use them. That was also deliberate. We don't want people to do it willy-nilly. But headers are never compressed, so they can be deserialized efficiently without having to deserialize the entire packet. And what we effectively do is we use this for routing information in our event system. So our event system, for instance, can put in the header a flag that says this is coming from, we have this term called persona, so we would say coming from persona app, right? And then the listeners that are receiving these events can actually deserialize out that tiny little piece of data and say, oh, I need to do something special with that. So I like to think of it as kind of like, imagine that a serial packet is like an envelope with a letter inside of it. And the header packet is basically the address information written on the outside that anybody can read. And the payload is the body, which is inside of the packet and potentially compressed. Now, we don't have support for encryption. I could imagine that coming in a future version. We'll see. Another cool thing is that our headers, we actually made a change to our headers in version 3 because we noticed that, well, a common problem in our infrastructure, and I believe probably in a lot of Perl shops, is the accidental UTF-8 upgrading of binary data, which then tends to cause horrible, horrible carnage, right? If you look at a string the wrong way, Perl will go, oh, I'm going to turn this to UTF-8, and then all of your binary turns into gibberish and bad things happen. So our header now has a high bit in the header that allows us to instantly detect. Our header has been encoded as UTF-8. We're not going to decrypt this packet at all. We'll just reject it as being malformed. I think there might actually be an option to auto downgrade and then decrypt or decode or something, I forget, but basically we wanted to know when that happens. You don't want to find out sort of halfway through the deserialization and then have some weird error like corrupt packet, right? When you can be told, somebody has UTF-8 upgraded your binary data. Please fix, right? It's a lot more helpful. Now, one aspect of this that I spent a little more time in the last week or so looking at than I really should have, is that there are a number of benchmarks and a number of people out there that have been benchmarking Sereal against CBOR and various other serialization packages, and then coming up with like some really bizarre numbers, right? So one of the tests that they do is they look to see how quickly can you serialize an empty hash, okay? Now, CBOR can serialize an empty hash at something like 600,000 a second, right? Perl can serialize an empty hash at about 400,000 times a second, right? So much, much, much slower in the percentage level, right? But the thing is, Sereal has header, which allows us to do a lot of interesting things, and CBOR and the competitors don't. And whoever serializes an empty hash anyways. Now, as we move forward, we will probably do our best to speed these things up as much as we can. We would like Sereal to be, I personally would like Sereal to be the fastest serialization package available for Perl. But the point is that we think the utility of having the headers is valuable, and if it slows down something like that down a little bit, we think the value that you get from them is an acceptable cost. And I really hate people that benchmark things like that. It's just so annoying. It's like, anyways, I thought I would give you a little bit of an idea of the difference. If you actually check out the repo, the Sereal repo on GitHub, we actually have a performance page which has these graphs along with a number of others. So this is for a large data structure. We just sort of created a large data structure with various crap in it. And then timed it. And here you can see the sort of relative performance differences. CBOR would be quite competitive with Sereal for what it's worth. So that's the encoding time. Now, encoding time is actually really important for us because, of course, we're sending these out from our web servers and things like that. So perhaps a little bit unusually, we focused more on the encoding performance than on the decoding performance, and it can encode faster than it can decode. I think that's not so bad. So Here's the size difference between the different ones. You can see message pack and Sereal are quite close to each other. With Snappy, it's a little bit smaller. Storable is considerably larger, as is JSON XS. DDL here is data dump limited, which is intended to be deparsed using data undump, which is a module I wrote to deparse data dumper dumps without doing eval. For simple data structures, it's actually significantly faster than evaling. On the downside, it's not complete and it doesn't handle cyclic data structures, and I'm relatively unlikely to finish that module. So if anybody's interested in picking it up, please get in touch. And then the decoding performance, you can see it's considerably faster than Storable, for instance. Zephram wrote a opcode, custom opcode implementation, which is what the Sereal font is. So you can basically, you pass in the object into a functional call, which actually ends up getting bound tightly to an opcode and blah, 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 blah. Again, with like serialize a hash, it makes a difference. With serialized large data structure, it doesn't make any difference at all. But, so some of the other languages that we have implementations for, Erlang, Go, Java, Objective-C, Python, and Ruby. I cannot claim any real insight as to how complete anything is other than the Go implementation, which, as far as I know, is basically complete. So you can read serial packets from Go with no problem, and you can construct serial packets in Go with no problem. The completeness of the Erlang, Objective-C, Python, and Ruby implementations, I can't attest to. I know that some real effort's been put into the Erlang one recently, but I can't really say much more than that. Again, anybody that's interested, please, we would love to see it. In particular, if somebody implements Sereal properly for Java, it would be incredibly awesome to be able to do Hadoop stuff and Hive stuff against Sereal data without having to convert it to JSON. And I think that would be a big win for the Perl big data universe. Why do we have to be stuck in JSON world? We should be able to go directly from Sereal into Hadoop and Hive and things like that without having to do a conversion to JSON, which is what we currently have to do. This is where the package is available. Yeah, feel free to check it out and send pull requests, whatever. If you want to implement it for a different language, let us know. We'll give you a commit bit, stuff like that. And then the little mandatory recruiting blurb, since they're paying for my flight. Yeah, there you go. Any questions?
How did you manage the transition from Storable to Sereal across making
Great difficulty.
With a certain amount of difficulty. There's a module called Data Flex Serializer that we wrote fairly early on before Sereal existed, which basically you can introduce into your code to give you an abstraction layer that makes it easy to swap out to a different serialization layer using Flex Serializer. So I think a lot of the time what we did was we migrated to using Flex Serializer with the same serialization. Then once we had everything running with Flex Serializer, we told Flex Serializer to start using Sereal. This is what we in booking refer to as the two-phase rollout problem. And typically in this scenario, what you have to do is you have to roll out code that handles both, right? And you need to handle both for some time. So a typical procedure for us would be we would roll out changes that support both. We would let them run for about 2 weeks. Once we got past like what we call the rollback horizon, we would, which is basically the point at which we think we're unlikely to roll back anymore or undo that change, then we start removing the support for the old thing. And this is a common, this is a common problem with anything, any software situation where you have external state, you're always going to have this problem. Like, I suppose a smaller shop maybe could arrange to like batch convert everything and then have the flip switch or something like that and go from one to the other. But an environment as large and crazy as ours, that's completely not possible. Any other questions?
Yeah, there was on the data sizes graph, there was a funny thing when the data dump or data dumper no indent was actually smaller than Storable.
Was it?
It is very surprising, I think.
Oh, yeah.
That was the one that I originally used, wasn't it?
Wondering what that would be. So Storable, you need to know a little bit about Perl data types here, but an SV contains it is basically the thing that we would normally refer to as a scalar, right, is actually a container object that contains multiple slots within it, one of which is a string, one of which is an integer representation. And then using various flags, basically Perl stores the fact that you stringified your data. It would not surprise me if Storable in this case is saying, I'm going to store both. So Perl has a data structure called an SVIV, and it has a data structure called an SVPVIV. A PVIV contains a string representation and an integer representation. An SVIV contains an integer representation only. For those of you who want to know more internals, an IV is actually stored as a bodiless SV, so all of the data is only in the header. So if you actually look at an IV in a dump, you'll see some slightly surprising numbers in some of the devel peak output. And basically what it does is it does the integer offset, it does an offset trick so that the IV slot, read it yourself. It's crazy. Basically what Perl does, Perl likes to use this trick. It pretends that the beginning of the SV actually starts about 10 bytes before the SV starts. And that happens to be the exact correct place so that the IV slot of an IV body lines up with the ref count, with the body pointer slot in the header, right? And this allows you to have light objects. Any undef references and pure integers are all stored like this as bodiless SVs. And so Storable would probably actually serialize the SVIV as raw as possible and the SVPVIV as full as possible. So that would probably explain that. Any other questions?
Are there any design decisions you made that now you think, oh, that was wrong, but...
Yes, absolutely. Absolutely. Serial is a tag data format. So we have a tag byte that basically says this is an integer, for instance, and then we have, let's say, a varint, some varint bytes following that tag. The high bit of that tag is reserved for what we call the track bit. And the track bit is basically when a decoder is reading and it encounters this high bit in the tag, it says, I need to remember this item once I've deserialized it, so that later on it can be referenced by its position in the serial packet. And this allows us to do a one-pass deserialization. We don't have to do a two-pass deserialization to resolve cyclic references and stuff. In hindsight, those type of data structures are a lot less common than I thought at first, and I should have just made that bit be a tag itself, which basically, instead of being a bit in the tag that says track me, it should have been a tag itself that says track the next tag, right? That would be one thing. Another thing that we're planning to fix for protocol 4 is that without thinking it through properly, there are two legal representations of the integers -16 to 15, which is a space optimization that we did. Integers larger than 15 or smaller than -16 are stored as a type byte followed by var data. Okay. Integers between -16 and 15 are stored only as a tag. So the low four bits or something of the tag are actually the value itself. And this allows us to like represent 10 zeros as 10 bytes, right? Instead of as 20 bytes. But the mistake was that we defined the larger integer definition to overlap, which then means you have a non-canonical scenario where you could represent two dumps two different ways and they're both legal. So in version 4, we've actually fixed that, and we've introduced two new tags that replace the larger integers that don't overlap. We haven't removed the old tags, we just now consider them non-canonical, mostly because it makes the decoder implementation easier for backwards compatibility to just continue to support them, but a compliant canonical encoder would never produce them. There's a few other little nits like that I might have done differently. I might have, in hindsight, I could maybe argue with myself that we should have serialized all the keys in a hash independently from all the values. It's a little debatable. I don't know, what else? Yeah, we could have handled floats better. I'm not super happy about how we handled floats. Floats are basically serialized as doubles, IEEE doubles. So they're just written to the wire as an 8-byte value. So we'll probably in a new release have support for fixed precision floats. So you'll be able to like set a flag to say, I want to send this in units of thousands, let's say, and then it would be able to represent it compactly. And I think I'm pretty well at 0 time now. So, thank you very much. If there's any other questions, feel free to